Okay, now good morning. So today we are discussing about last class I had until correlations. Okay, Carl Pearson's correlations. So today I am discussing Spearman's coefficient of rank correlation. Spearman's coefficient of rank correlation. Spearman's coefficient of rank correlation. Easy. Just try to understand. First I'll discuss the theory behind that. Theory questions will not come in the exam, only problems. In a bivariate data means two variables. Variate means variable. Bi means two. A bivariate data. So if the values of the variables are ranked in the values of the variables are arranged in the decreasing or increasing order. So in two variables, if the variables, that means the variables have to be arranged either in increasing or decreasing order. The variables have to be arranged either in increasing or decreasing order. Okay, the correlation between these ranks, when they are arranged in between increasing or decreasing order, the correlation between these ranks is called as rank correlation. The correlation between these ranks is called as rank correlation. Okay, then is called rank correlation. The coefficient of correlation computed for these ranks, the coefficient of, when we calculate the coefficient of correlation for these ranks, that is calculated, or it is found out by using Spearman's coefficient of rank correlation. That is found out by using Spearman's coefficient of rank correlation. It is denoted by rho. It is denoted by rho like this, denoted by rho, RH, rho. Now, if R1 and R2 are the ranks in the two characteristics under study, if R1 and R2, you will understand more when we solve problems, okay? If R1 and R2 are the ranks in the two characteristics under study, and if you take D as R1 minus R2, D is the difference of R1 and R2, then coefficient of correlation is given by the formula rho. This is called rho. Rho is equal to coefficient of rank correlation, that is Spearman's rank correlation, is given by the formula rho is equal to 1 minus 6 sigma d squared divided by n cubed minus n. Rho is given by 1 minus 6 sigma d squared divided by n cubed minus n. N is the number of items. D is the difference between the two ranks, that is R1 minus R2 or R2 minus R1, whatever. The value of rho is always in between minus 1 and plus 1. The value of rho is always in between minus 1 and plus 1. The value of rho lies in between minus 1 and plus 1. Always the value of rho lies in between minus 1 and plus 1. You should know. The value of rho lies in between minus 1 and plus 1. If it crosses 1, then something is wrong in the answer. Okay, it is in between minus 1 and plus 1. The problems. See, the first problem, the following are the marks of 8 students. The following are the marks of 8 students in statistics and mathematics. Find the coefficient of rank correlation. Find the coefficient of rank correlation. So, problem is given like this. Marks in statistics, 25, 43, 27, 35, 54, 61, 37 and 45. So, total how many students? 1, 2, 3, 4, 5, 6, 7, 8. First student, he got so many marks. Second student, third student, like that. Marks in mathematics. Marks in mathematics will be 35, 47, 20, 37, 63, 54, 28 and 40. This is the question. What you have to find? Find the coefficient of rank correlation. So we have to find the coefficient of rank correlation. So you can see here, first we write the marks. So see the columns, how it has to be done. First we write the marks, that is first column we write X, second columns we write Y. First we write the marks. First column we write X, second column we write Y. Okay, so X, so all these values are written 25, 43, 27, 27, 35, 54, 61, 37 and 45. Second column we write the marks in mathematics. We have taken marks in statistics as X and marks in mathematics as Y. So 35, 47, 20. So 35, 47, 20, 37, 63, 54, 8, 28 and 40. Okay. Now we find the ranks. Okay. We find the ranks. Ranks is given R1 and R2. So rank is taken as R1 and R2. R1 and R2. Okay. Rank is taken as R1 and R2. So how to find the rank? See, the first R1, is R1 is the rank R1 is given for the variable X, that is marks in mathematics. R2 is given for marks in statistics. Any order, that is your wish. Now the highest is 61, so we give it the rank 1. Highest is 61, so we give it the rank 1. Okay, not your own, as it is. Highest 61, so it is 1. And second highest is 54, if you see in this 54, so rank 2. And the third highest is 45, so rank 3. And the fourth highest is 43, so rank 4. Next highest is 37, so rank 5. Next highest is 35, so rank 6. Next highest is 27, so rank 7. The last is 25, that is 8. So like this you have to see and give the ranks. So the question might come, if two numbers are same, if two students are getting same marks, then how to give the rank? Repeating is not there in your syllabus. Repeating is not there in your syllabus. You don't worry. Only different ranks. Then R2, that is the marks in statistics. Marks in statistics. So here you can see highest is 63, so rank 1. Second highest is 54, so rank 2. Third highest is 47, so rank 3. You can see there, very clear, very simple. Fourth highest is 40, so rank 4. Fifth highest is 37, so rank 5. Sixth highest is 35, so rank 6. Next, the highest is 28, next comes, so rank 7. And the last is 20, that is rank 8. So like this, you have to assign the ranks. So once you have assigned the ranks, then comes the concept of how to calculate. Okay, then we find out D. D is equal to R1 minus R2. First one minus second one. Second one minus first one. So possible you do R1 minus R2. 8 minus 6, 2, 4 minus 3, 1, 7 minus 8, minus 1, 6 minus 5, 1, 2 minus 1, 1, 1 minus 2, minus 1, 5 minus 7, minus 2, 3 minus 4, minus 1. So once you have got D, then find D squared. D squared means you get 2 squared 4, 1 squared 1, minus 1 squared 1, 1 squared 1, again 1 squared 1, minus 1 squared 1, minus 2 squared 4, 1 squared 1, add it, sigma D squared is 14. We want here sigma D squared. When we add it, we get sigma D squared as 14. Now the coefficient of rank correlation, formula is rho equals 1 minus 6 into sigma D squared by n cubed into n. The formula is rho. The rank correlation is rho 1 minus 6 sigma D squared divided by n cubed into n. So 1 minus 6 into sigma D squared is 14. So 1 minus 6 into 14 divided by n is 8. The number of 1, 2, 3, 4, 5, 6, 7, 8. Number of students. So 8. 8 cube minus 8. Then this is a simple calculation. You can use your calculator and find out it is 0.8333. So it is very near to 1. So we can say that there is a high positive correlation. We can say that there is a high positive correlation between marks in statistics, and there is a high positive correlation, because if it's more than 0.5 we say high, below 0.5 we say it's low. So here you can see the answer is 0.833. Please calculate, I might be wrong, use the calculator. There is high positive correlation between marks in statistics and marks in mathematics. Okay, now we'll see another question. 6 students are ranked. So in this problem, they have already given the ranks. 6 students are ranked in sports and studies. 6 students are ranked. So here they are given rank. Directly they are given rank. 6 students are ranked in sports and studies as follows. Find the coefficient of rank correlation. So rank is given directly. So your work is reduced. So here we get student 1, 2, 3, first student, second student, third, fourth student, fifth student, and sixth student. For the first student, rank in sports is 1, rank in studies is 4, as given in the question. For the second student, rank in sports is 2. For the second student, rank in sports is 2, rank in sports is 2, and rank in studies is 5. For the third student, rank in sports is 3, and rank in studies is 6. For the fourth student, rank in sports is 3, rank in studies is 6. For the fourth student, rank in sports is 4, rank in studies is 2. For the fifth student, rank in sports is 5, rank in studies is 1. Okay. For the sixth student, rank in sports is 6, rank in studies is also 3. So now here, so we get here what we do first. So directly rank is given. So no need of X and Y, directly rank in rank. So rank we write R1 and R2. First we write R1 because rank is given directly in the problem. There is no question of finding rank here. So first student, that's rank in sports and rank in studies. So we write all this. What is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And second rank is 4, 5, 6, 2, 1, 3. So 4, 5, 6, 2, 1, 3. So we find D. D is R1 minus R2. So D is R1 minus R2. So very simple. 1 minus 4 minus 3, 2 minus 5 minus 3, 3 minus 6 minus 3, 4 minus 2, 2, 5 minus 1, 4, 6 minus 3, 3. Then we find D squared. Then we find D squared. D squared means minus 3 squared is 9. Again, minus 3 squared is 9. Minus 3 squared is 9. 2 squared is 4. 4 squared is 16. 3 squared is 9. So sigma D squared is 56. Sigma D squared is 56. Now, the coefficient of rank correlation we have to find. That is the question. So, rho is equal to 1 minus 6 sigma D squared by n cubed minus n. So, n is here how much? 1, 2, 3, 4, 5, 6. So, 6 inputs. So, 1 minus 6 sigma D squared is 56. Sigma D squared is 56 divided by n cubed minus n divided by 6 cubed minus 6. That is 1 minus 1.6. This value will be 1.6. So 1 minus 1.6 will be minus 0.6. So you can see negative. So there is a negative correlation between performance in sports and performance in studies. So there is you can see negative value, minus 0.6. So there is a negative correlation between performance in sports and performance in studies. So this negative correlation means there is no sports he might be more, studies he might be less. Like there is nothing connection. So negative correlation. So you can make out correlation means last class we have discussed about it. Next question we'll see the following are the sales statistics of 6 sales representatives. The following are the sales statistics of 6 sales representatives in 2 different weeks. The following are the sales statistics of 6 sales representatives in 2 different weeks. Find the Spearman's coefficient of rank correlation. Find the Spearman's coefficient of rank correlation. So, sales statistics of 6 sales representatives in 2 different weeks. Find the Spearman's coefficient of rank correlation. So, representatives, this is representative 1. His first week sales is 60, second week sales is 90. Representative 2, first week sales is 110, second week sales is 100. Representative 3, first week sales is 65, second week sales is 80. Representative 4, first week sales is 40, second week sales is 30. Representative 5, first week sales is 70, second week sales is 70. Representative 6, first week sales is 20, second week sales is 20. This is the data given. This is not the rank. So the rank is not given here. 6 representatives are there. So we have to find the Spearman's coefficient of rank correlation. Okay. So first we write the sales. That is, we prepare the first week sales. I'll take X. The variable X I'll denote for first week sales. Variable Y I will denote for second week sales. So X and Y I will get 60, 110, 65, 40, 70, 20 as given here. 60, 110, 65, 40, 70, 20. Second one is 90, 100, 80, 30, 70, 20. So 90, 100, 80, 30, 70, 20. Okay. Now we put rank. So ranks. So R1 for the sales, that is X. So highest is 110, so 1. Then second highest is 70, so second position. Third highest is 65, so 3. Fourth highest is 60, 4. Fifth highest is 40, so 5. And last is 20. I hope it's correct. Just check, I might be wrong. R2 is the rank given to Y. First highest is 100, second highest is 90, third highest is 80, fourth highest is 70, fifth highest is 30, and the last is 26. Then once you have denoted the ranks, then you find D. So D is given by R1 minus R2. So 4 minus 2, 2, 1 minus 1, 0 as it is. 3 minus 3, 0, 5 minus 5, 0, 2 minus 4, minus 2, 6 minus 6, 0. Then we find D squared. So 4, 0 squared, 0, all zeros. Minus 2 squared for 4. So total sigma D squared is 8. Total I get sigma D squared is equal to 8. Okay. Total I get sigma D squared equals 8. Now coefficient of rank correlation rho equals 1 minus 6 sigma D squared divided by n cubed minus n. coefficient of rank correlation rho equals 1 minus 6 sigma d squared divided by n cubed minus n. So 1 sigma d squared is 8. 1 minus 6 into 8 divided by n is 6 here. 1, 2, 3, 4, 5, 6, 6 inputs. So 1 6 into 8 divided by 6 cubed minus 6 n cubed minus n. So 0.7714. 0.7714. So this you can see there is a high positive correlation. There is a high positive correlation. So this is a high positive correlation between sales in the first week and sales in the second week. So there is a high positive correlation between the sales in the first week and sales in the second week. High positive correlation between sales in the first week and sales in the second week. Okay, it's clear. Okay. Now after this concept, we go to the concept of next concept, that is that's all the problem in rank correlation. Solve the problems in the model question paper. It is easy. Okay, I leave it for you. I leave it to you to solve. And suppose you don't get, we'll see later on the college portion is over. Okay, more about it. We'll see more about it when the portion gets over, and after the fifth module, we'll discuss the model question papers. Now, regression. The property of the tendency of the actual value to lie close to the estimated value is called regression. See, the property of the tendency of the actual value. The property of the tendency of the actual value to lie close to the estimated value is called regression. That means when we estimate some value, there will be a tendency for the actual value to be close to the estimated value. There will be a tendency for the actual value to lie close to the estimated value. This property of the this property or the tendency of the actual value to be close to the estimated value is called as regression. It's called as regression. I hope you understood this. Just a definition. So what the definition? The same generalized in the form of definition. What explanation I gave now? It is generalized in the form of definition. Regression is the theory of estimation. Regression is the theory of estimation of unknown value of a variable. Regression is the theory of estimation of unknown value of a variable with the help of known values of the variables. Regression is the theory of estimation of unknown value of a variable. Regression is the theory of estimation of unknown value of a variable with the help of known values of the variables. Regression is the theory of estimation. So it is the theory of estimation of unknown value of a variable. So it is a theory of estimation of unknown value of a variable with the help of known values of the variable. So it says, see, the definition itself says the meaning of that. Regression is the theory of estimation of unknown value of the variable, estimation of unknown value of the variable with the help of known value of the variable. So the estimation of unknowns with the help of the knowns, what you know, with the help of the knowns. Okay. So now, here you will see definition. Regression is the theory of estimation of unknown value of the variable. Estimation of unknown value of the variable with the help of known value of the variables. Okay. For a bivariate data, usually you consider in your syllabus bivariate data only, that is two variables. For a bivariate data on x and y, for a bivariate data on x and y, the regression equation obtained with the assumption that, see, for two variables x and y, the regression equation obtained with the assumption that x is dependent on y. So with the assumption that x is dependent on y is called regression of x on y. So regression of x on y means x is dependent on y. Regression of x on y means x is dependent on y. So the regression of x on y is given by x minus x bar equals bxy into y minus y bar. The regression of x on y is given by x minus x bar is equal to b of xy into y minus y bar. So derivation is there. For you, no need of derivation. So regression of x on y means what? X is dependent on y. Regression of x on y means it clearly says x is dependent on y. Okay, x is dependent on y. So regression of x on y means x is dependent on y. The equation, the regression equation of x on y is given by x minus x bar equals bxy into y minus y bar. For you, no need of derivation. Equation of x on y means x is dependent on y. Its equation is given by x minus x bar is equal to b of xy into y minus y bar. The regression equation obtained with the assumption that y is dependent on x. If y is dependent on x, then it is called regression of y on x. That is just like this. Replace y by x and x by y. The assumption that y is dependent on x. The assumption that y is dependent on x is called regression of y on x. The assumption that y is dependent on x is called regression of y on x. Okay? It's called regression of y on x. So now the assumption that, once again, the assumption that y is dependent on x is called the regression of y on x. The assumption that y is dependent on x is called regression of y on x. And its equation is, just here replace x by y and y by x. So y minus y bar. Regression of y on x means y is dependent on x. Y minus y bar equals byx into x minus x bar. Byx into x minus x bar. Byx into x minus x bar. Okay. Now the constants bxo, you can see here some constant is the bxo and byx. The constant bxo and byx are called regression coefficients. The constants bxy and byx are called the regression coefficients. Here the constants bxy and byx are called the regression coefficients. The constants bxy and byx are called the regression coefficients. So bxy equals r into sigma x by sigma y. This is a very important formula for you. Bxy equals r into sigma x into sigma y. Byx equals r, and just change x and sigma y by sigma x. So if you know one, you can write the other, replace x by y. So the regression coefficients bxy and byx are given by the formula bxy equals r into sigma x by sigma y. And another formula for that, this is not so important, for this is very important, r into sigma x by sigma y. Another formula is n into sigma xy minus sigma x into sigma y divided by n sigma y squared minus sigma y whole squared. Here byx equals r into sigma y by sigma x, that is equal to n into sigma xy minus sigma x into sigma y divided by n sigma x squared minus sigma x whole squared. So very important is the regression coefficients bxy and byx given by pxy equals r into sigma x by sigma y, and byx is equal to r into sigma y by sigma x, r into sigma y by sigma x. So once again I will just first explain what we did today. First we studied the coefficient of rank correlation. In today's class we started in the module 4, we started with the coefficient of rank correlation. So how the given variables will be given their values, find their ranks, assign the ranks to them depending on the magnitude. Then find the difference, d is equal to r1 minus r2, then d squared column. Then use the coefficient of rank correlation, that is rho. Coefficient of rank correlation rho equals 1 minus sigma d squared by n cubed minus n. 1 minus sigma d squared by n cubed minus n. Okay. But sometimes in the problem they give the rank directly. If they give the rank directly, no need of assigning the ranks, directly you can calculate. Okay. Very simple problem you can solve. The problems which are simple you solve, which are difficult we will see at the end. Now, then we started the concept of regression. The property of the tendency of the actual value to lie close to the property of the tendency of the actual value to lie close to the estimated value is called as regression. So regression is the theory of estimation of unknown value of a variable with the help of known values of the variables. Theory of estimation of unknown value of the variable with the help of the known value of the variable. So it is estimation theory of regression means the theory of estimation of the unknown values of the variables with the help of the known values of the variables. Okay, with the help of known values of the variables. Now, for a always we consider a two variables, that is bivariate means two variables x and y. The regression equation obtained with the assumption that x is dependent on y. The assumption that x is dependent on y means regression of x on y. the assumption that x is dependent on y means the regression of x on y. X is dependent on y means regression of x. So the regression of x on y or x is dependent on y, the regression of x on y is given by the equation x minus x bar is equal to bxy into y minus y bar. The regression of x on y is given by the equation x minus x bar is equal to bxy into y minus y bar. Derivation no need, only equation. The regression equation obtained with the assumption that y is dependent on x. The regression equation obtained with the assumption that y is dependent on x is called regression of y on x. Obtained with the assumption that y is dependent on x is called regression of y on x. The regression of y on x is given by y minus y bar equals byx into x minus x bar. The regression equation of y on x is given by, so you see the difference, wherever x put y. The derivation is there for this, but for you it is no need at time being. Okay. Now here the constants you can see, that is bxy and byx. The constants bxy and byx, they are called as regression coefficients. The constants bxy and byx are called as regression coefficients. They are called as regression coefficients. You can see here bxy and byx, they are called as regression coefficients. Regression coefficients. Okay. Now the formula for regression coefficient, that is bxy, is given by r into sigma x into sigma y. The formula for bxy is given by r into sigma x by sigma y. Okay, the r, what is this r? We'll see later. That's the rank correlation or the coefficient of correlation, what we'll see later. R into sigma x means standard deviation of x, sigma y means standard deviation of y. So another formula for that, mostly we are using this formula in your syllabus, r into sigma x by sigma y. Also there is another formula to make it easy for you, n into sigma xy minus sigma x into sigma y divided by n into sigma y squared minus sigma y whole squared. Minus sigma y whole squared. Okay. Now byx, once you know bxy, just you replace. Once you know bxy, to find byx, replace x by y usually. So what we get here? R into sigma y by sigma x. R into sigma y by sigma x. So we get r into sigma y by sigma x. So the formula for that in terms of x and y is n into sigma xy minus sigma x into sigma y divided by n into sigma x squared minus sigma x whole squared. N into sigma x minus sigma x whole squared. Okay. So next class, that is tomorrow at 12, the next session, we will discuss the problems in regression. So to wind up today's class, I will just recall what you have done today. So first we solved the problem in Spearman's coefficient of rank correlation rho, which is given by rho equals 1 minus 6 sigma d squared divided by n cubed minus n. 6 sigma d squared divided by n cubed minus n. This rho value is in between minus 1 and plus 1. So whenever the question is given, if the rank is not given, we find the rank. So we put the rank, highest one first and the lowest one least, like that. R1 and R2 for y and R1 for x, like the two variables. Then we find D. D is equal to R1 minus R2. D is equal to R1 minus R2. Then we find the last column is D squared. Once you get sigma D squared is 14 here, the coefficient of rank correlation rho equals 1 minus 6 sigma D squared by n cubed minus n. So this has got a high positive correlation between the marks of statistics and marks of mathematics. Next problem, if you see here, in this problem, they given the ranks directly. That is rank in sports and rank in studies. So directly return the rank, difference is found out and d squared, and the coefficient of rank correlation is calculated. Here you see negative correlation between the rank of performance of students in sports and performance of students in studies. That means if a student is good in sports, it's not necessary that he be good in studies. Or if he is good in study, it is not necessary that he be good in sports. But they can be, some can be good in both. So here the next problem, you can see the following are the sales of statistics, sales statistics of sales representatives. So 6 representatives, first week sales and second week sales. So here the rank is not given. We find out the rank, find D R1 minus R2, then sigma D squared and calculate. We get a high positive correlation. Then we saw the concept of regression, which is the theory of estimation of unknown value of a variable by using the known values of the variable. It is the theory of estimation of unknown values of the variable. Regression is the theory of estimation of unknown values of the variable by using the known values of the variable. So there are for two variables x and y, x is dependent on y means the regression of x on y, that is x minus x bar equals bxy into y minus y bar. Y is dependent on x means the regression of y on x, that is given by y minus y bar equals byx into x minus x bar. bxy and byx are called regression coefficients. They are calculated by these two formulas. Main formula is r into sigma x by sigma y. Otherwise, if x and y is given this formula, byx is calculated as r into sigma y by sigma x. If x and y only are given, this formula. This is standard deviation. Okay. So with so much, we wind up the class session today. Tomorrow also we are continuing. We are solving problems in regressions. Okay. All of you can try the model question paper problems. And once again, I'm remembering you. All of you write the notes. It is assignment, and you will not get time later. You have to start preparing for the exam. Then also assignment 1, you do it. Okay, I'm going to check when the college reopens. Okay, so those who missed the class, please see this video on the YouTube, which will be uploaded in the afternoon in the MITK channel. Okay, so I wind up the session. Thank you. All the best.